Thanks for coming to Intrinsic booth. And today I want to talk about a project that we've been working on, which is the AI for Industry Challenge. Now, who here has heard of the AI for Industry Challenge? All right. Who is working in manufacturing? Come on, raise your hand. Raise your hand. All right. All right. So the AI for Industry Challenge is a challenge that Intrinsic has been organizing around electronic assembly. And it's a global competition where we ask people to tackle some of the hardest problem, which is cable handling. My name is Baraglia, and I'm a senior software engineer at Intrinsic, which is a Google AI robotic group. And today I'm going to talk about the AI for Industry Challenge. So first of all, I want to ask the question together, why are we even organizing an AI challenge? Why is a company like Google interested in AI and cable handling? I want to talk a bit about the response from the community, as well as how we built the challenge, how we got it from an idea to a challenge attracting thousands of participants. Then I'm going to talk a little bit about Intrinsic missions. And then if you have any questions, I'll be happy to answer them. So the idea to build an AI challenge was to bring together software developers, AI researchers, people that do not have experience with robotics together as a developer community to tackle one of the hardest challenges that we've seen in electronic assembly, which is cable handling. We ask participants to come in to use any tool they like to develop an AI model to tackle the last inch insertion of cable assembly. They bring the state-of-the-art technology to electronic and at the same time try to bridge the seam to real gap. All right, so why cables? Cables are everywhere in electronic manufacturing. You can find them from copper coupling to network to even modular servers. At the same time, cables are very hard to solve with automation. In terms of robotics, you have to model flexible cables that are not trivial even for state-of-the-art simulators. In terms of perception, there are different types of cables, sometimes in a really cluttered environment, and traditional perception models just don't work for cables. Motion planning is also a very challenging problem. When you work in free space or with rigid body, it's relatively easy. But when you go to cables and dense networking, then it becomes a whole lot harder. Grasping is also really hard because connectors get fragile and really require sensitive sensor-based control. And finally, and most important, we lack the data to train capable AI model to solve this challenge. At the same time, why do we need this now? Well, you're all familiar with AI tools and the rise of ChatGPT, Claude, but the demand for AI infrastructure to power them is also at a all-time high. Companies are struggling to keep up with the demand from Google, from NVIDIA, to produce servers and AI accelerators to feed into the AI infrastructure. And at the same time, labor is becoming more expensive. And so we need to build something that both solves the problem of the demand and the problem of the labor shortage. And so what if we could use AI and the new generation of AI model to solve the challenge? And how can this AI actually solve the big problem from manufacturing? And that's why we kind of set ourselves to find during this challenge. Now, if you're not familiar, we've started actually a few months ago. We asked participants to download our toolkit and to generate a model to solve different types of cable assembly. So we have SFP and optical cable assembly. And the participants have 3 months to generate a model and test it on our gazebo simulation. At the end of the 3 months, a few teams qualify to phase 1, where we give them access to intrinsic flow state, and they have to build an end-to-end application using our tools and integrating their model for cable assembly. And in a month from now, they're going to access to phase 2, where they're going to deploy their model onto real hardware, and the winning team will get $100,000 cash. And this is kind of a preview of the hardware that we built for the cell. Now, we got a lot of traction from this challenge. we're setting ourselves to maybe get a few hundred people, like a couple of universities to come in. We were overwhelmed by the response and the number of not only university, academic, but also industrial partners that partnered with us. In fact, only in the first 2 weeks, we got almost 50,000 downloads of our toolkits and message from different open source community telling us that they're starting the challenge and are working on it. At the end, we got over 5,000 participants, over 1,600 submission of different AI models from 115 countries. And what really surprised us is that almost half of them were not academic. Half of them come from companies like Intrinsic or like startups building solutions. And that tells us that the industry is actually ready for a shift. They see the need, they see the bottlenecks, and they want to find a solution to that problem. And here's a sneak peek at our leaderboard. And the maximum score that a team could get is 300, and you can see some of the team are actually getting quite close to that. And here's a video of one of the team succeeding on the task. So you can see the two tasks. Here is inserting a network cable into a network card. And this was all trained only using synthetic data. And then finally, like changing cable completely and trying the same model on a completely different task. And this one in particular was able to generalize to the new task. All right, a few behind the scene. So when we set to ourselves to do the challenge, we did not have a good idea of how we wanted to solve our problem. We just had a vision to bring together a community of developers together to solve that challenge. We had some goals to tackle electronic handling, electronic cabling and robotics, as well as to democratize access to robotics for people that do not usually work with robotics. And we worked together and we decided why not organize a challenge where everybody can come in and bring their own expertise into the fold. We also did not work on this on our own. So we leverage the existing community. We leverage the people that organized challenge in the past. And we did try to not reinvent the wheel. So we work really closely with some of the team that organized the DAPAR picking challenge. And they help us kind of figuring out some of the logistic details. How many phase, how long, what resource we need to give to the participants, and so on and so forth. We also came in with a really good idea of what kind of people we wanted to attract. Like we wanted to both attract academic, but also engineers that are working on that problem, as well as end customers that need a solution to this specific problem. We wanted people that are focused on automation, but also specialized in AI, open source tools, and modern software. And ideally, these people don't have experience with deployment, so they can rely on us and on FlowState to handle the sim to real deployment. Now, along the way, we find a few issues, like is the task board too difficult? Like one person will tell us it's too easy, one person will tell us it's too hard. So like, how do we find the right middle? Or are we using the right tool to attract the right community? Can we provide the team with enough computing resources to make the challenge fair to everyone? Do we have a good enough simulation? Is the challenge accessible? And again, to solve the question, we work together with amazing partners and previous organizers to help us. We also did a bit of social media share. So we really wanted everybody to know about the challenge so that everybody could come and participate. So we had a few LinkedIn posts. We hosted a few webinars, which you can still watch. And we also got contacted by a YouTuber who wanted to make a video about the AI challenge, which was quite exciting. We also partner with amazing technological partners. So Amit Goel, which was here earlier, which is director at NVIDIA. Susan Nodinger, which is the head of ecosystem for UR Robotics. Dr. Zaishi, which is the chief digital officer at Foxconn. Geoffrey Biggs, working with the open source community. Francesco Nori from Google Deepmind. And of course, Wendy Tan-White, which is the CEO of Intrinsic. I would say the most important thing for us was to really build this challenge for the community. So as Intrinsic, we're not trying to own their code. We just want to give them an opportunity to use robotics and deploy the AI. So we really focused on their experience. We balance their difficulty. We prioritize making sure that they were not blocked on anything. We foster community engagement, and we ensure transparent evaluation throughout the process. All right. So we mentioned that earlier. The approach that Intrinsic is taking is bringing AI first to tackle some of the most complex problems in automation. So building on top of our platform, we can integrate state-of-the-art models to solve any type of challenge, such as cable handling. And we're doing that because we are seeing that the industry, and you see that at Automate, is ready to shift from hard-coded manual automation to an AI-driven, flexible one. So we bring together software developer, AI scientists, even like people that want to start in robotics together through our tools to give them access to this developer ecosystem and powerful automation tool. And in our turn, we abstract away all the complexity of bringing your state-of-the-art model to the real world through automation. And at the same time, through the challenge, we provide a very rigorous world stage to make sure that the models are not just proof of concept, but actually safe to operate into manufacturing environment. Again, Intrinsic mission is to democratize access to robotics and to unlock productivity for AI developers and manufacturers. Thank you.